corners. Aren't the corners round? Yeah, they are. The corners are rounded. The corners have a 1/4 inch round to them. So what I'm going to do, I don't have a compass on me. So I am going to show you, especially when it's this small. You see how I put a little dot for position? And then I'm going to put another dot for vertical. I'm going to make sure this is caught in the video. Sorry. Is it a 1/4 inch or 1/2 inch, guys? 1/4 inch, right? Yeah, 1/4 inch. So I'm going to then go across. I'm lazy, so I'm going to go across all of it, not just one side. Here's my vertical position. I've got my tiki right there, so I just position it. I should do the vertical 2 lines as well, right? These 2 vertical lines, so the position of these needs to be known. They are 1 inch from the top. 1 inch from the top. So if I go 1 inch down from the top, that's there. And now I can draw my vertical position. See how I'm making sure my center lines are perfect? You can only do this by hand. When you move to CAD, you give it up. Because center lines in CAD, I don't care which CAD product we're talking about, do not operate this perfectly. Only by hand do you get this perfect, they match. Of the center crosshairs being right at the center where the circles are. Once you know this, this is an arc. If you happen to have something that matches the arc, which I don't, you never know. I'm looking. I'm looking at the corners of things. You're going to have to use your compass. I don't have mine, and I don't think I have a normal circle template on me as well. If you have neither, you're going to love the way I'm going to teach you to do this. If you have neither a circle template nor a let me see if my paper clip works. Nope, no paper clip. See how I'm looking to MacGyver it? See what I'm doing? I'm doing that intentionally. So you can see, if you can find something that's close, for a hand drawing, it's okay. If you cannot find something that's close, then you are stuck doing it by hand. What's nice is when you're working on a board, you can actually take 2 pencils. I'm showing this just so you know how to do this. This is a trick. Not saying it's a great trick, but it works. Where you use 1 pencil as your guide. See that? And if you have the spacing about right, because what's the spacing? If it's a 1/2 inch radius, I'm sorry, it's a 1/4 inch radius, so the spacing needs to be about 1/4. These 2 pencils are too far away. Who's got another? Let me see if I use one of my colored pencils. See, my colored pencils, if I get them close enough, let's see. No cigar. See that? They are not quite 1/4 inch away. They are close, though. Do you see that? They're close. So you could always tape 2 pencils together, especially if it's just a 1/4 inch, or if you know what the gap is. And 1 pencil becomes the center. I have to switch these because the colored pencil for mine is going to become the center. And then the other pencil becomes the tip. See, I'm not going to be able to do it right because I don't have, they need to be taped together to make this work. It's a little too tricky. So what I'm going to end up doing is making a 1/4 circle, not a half circle, by hand. Okay, so it's like making half a smiley, but it's a 1/2 circle. See that? I did it by hand instead of using the other tools. I would argue that it's better for you to have the right tools in front of you when you're doing it. So a circle template would be great. But if you're on the fly at a customer's site and you just got to get it done because they want to see something rather quickly, that's what you do. You improvise, okay? So I had to improvise there because I don't have a circle template handy. One of you is actually using your drill gauge, right? If I remember correctly, you're actually using a drill gauge as your circle template. Can I borrow that one real quick? Because the next one, because a drill gauge is a circle template. Don't let anybody tell you it's not. So, thank you. So this is her drill gauge right here. Rafaela's. See that? She built it in a different class, and it is radiated. It's kind of hard to see. If I tilt it a little bit, you might be able to see. Because we made it on our laser in the lab. So what are the diameters of the circles? They're very tiny. The inside, whoops, let me move that over a bit. The inside diameter is 1/8 of an inch through, and the outside diameter, the counter bore diameter, is 1/4 inch, and it only goes 1/8 inch deep. So if we look at that, 1/8 inch on here is pretty tiny. That's this one where I'm pointing to. So it's a very tiny little hole. See that? So my head's probably going to get in the way of my monitor because I can't quite see what I'm doing because my phone is right on top of this thing. So I'm going to move this out of the way, and I'm actually going to hand draw this because I can't physically use this template the way I'm set up in front of this lab right now. Okay? So that's about 1/8 of an inch. I know this one's off. I could tell just by looking at it. So my circle is off. The other one is 1/4 inch. That one I could be a little more precise with if I use my ruler and just gauge it. Because 1/4 inch is from here to here. Notice what I'm doing? I'm putting little tick marks to reference where the 1/4 inch ends. Here and here. And then I'm going to freehand draw a circle. If this paper was not taped down, I could actually twirl the paper to draw this and get it done faster. So, but you see how small that is? Okay? A circle template, these are examples of where would I want a circle template. Let me look at my stuff here one more time just to verify that I don't have one on me. Just like I thought I didn't have the other template on me, and I did. Ah, nope, no circle template in here. Check everything out just to see. The answer is no. I'll put all that stuff back later. Okay, so no circle template. So and no compass in front of me. So I'm going to end up free-forming this using my reference geometry. It's not going to be pretty. You notice that? This is what happens when you don't have the correct toys in front of you. So the lesson of the day is do what? Have the right toys in front of you. Got it? To me, everything's a toy. Whether I'm welding or whether I am hand drawing something. And if you're on the welding side, as I know several of you in this room are, being able to at least do reasonable hand sketches with reasonable looking circles is very commendable. Okay? When you're on the job site, trust me on that one. All right, so that's really bad circles. But here on this side, the center marks are perfect. The circles are not, which means our centers over here will be perfect in the right side view. So when we carry this over, this will come out very nice. Now, the counter bore diameter was a, what was it again, 1/4 inch? Counter bore diameter was 1/4 inch. So what I'm doing is positioning where the 1/4 inch mark is at each of these spots. And it only went 1/4 inch in. No, it went 1/8 inch in. I take that back. It went only 1/8 inch in. an 1/8 inch in. So when I look at what I'm going to draw, I'm going to draw the hidden line representing the counterbore depth, which is an 1/8 inch, and I'm going to close this off. See that? So that looks like little U's, right, on the side, sideways U's, because that's what they look like. See that? That's the counterbore part. Now the next part is the through hole. And the through hole is only an 1/8 inch wide, so it's a lot narrower, so it's only from there to there. And the same here, from there to there. And now I'm adding those lines in. It's only 2 little dashes. It's not much, because this is a very small drawing. So there's that. Okay? Now this view is not darkened up nicely. That I can do next, so you can see how the right side view will look a little neater. See, now I can, once I've drawn everything in, then I can darken up my lines. Because everything is here, all you're doing is going over the lines that are existing on your drawing. And that's it. To clean up the front and the right side view. Then of course you're going to have to clean up the corners, and that's what your eraser shield is for, to clean up the corners. And the view that you need to put in next, this is what's called an auxiliary view, because I can't dimension this cleanly here, correct? Because it's an oblong shape, and I can't dimension it here because it's hidden. You never dimension to something you can't see. The builder will not like you if you do that, meaning me, the person who's on the shop side actually making the product. I'm not going to like you. Because I won't know what the heck you're dimensioning to. So what we do to offset this is what we call an auxiliary view. Now in my case, these two are too close together, so I cannot project my auxiliary view from this face out. So I'm going to project it backwards instead. Because it's acceptable either way. Annoying, possibly, but acceptable. You'll notice how I'm carrying my lines down for where everything goes. Position the pencil first, then draw the line. Position the pencil first, then draw the line. Remember that, okay? And then where do I start my view, my auxiliary view? I recommend at least 1 inch away from the object you're auxiliarying from. Got it? At least 1 inch. And of course, out of the way of everything else on your drawing. So about 1 inch away is where I'll start this view. And that's the edge of it. Right here. This will be the edge of it. I drew that darker. It's 1.25 is the width, right? Of this object. So the halfway point is 5/8. So 5/8 is the center. 1.25 is the width. Because I drew in my reference lines down, all I got to do is draw my lines up. That's it. I don't have a lot of, everything's set up for me. All I have to use is my 45-45 triangle. See that? And then I really do need a real compass, because now I'm drawing a normal circle. Because this one's going to be the inside circle is a 1/2 inch. This outer circle is a large radius. A very large radius. So let me see if I got a compass here. And I do. One of these. Okay. And make sure it's tight, so it's not going to come apart while you're trying to work with it. Needle ends are there, nice and sharp. See that? For positioning purposes, you're positioning based on the radius. So in our case, if it's a 1/2 inch diameter, it's a 1/4 inch radius. You never take this and directly punch your paper with it. Got it? What do? You take a little piece of tape, small piece of tape, put it where your center is. I have my center mark already there because I had referenced my lines down, and then I just referenced my lines across. So my center was already marked. That's why I could just drop down. So you have to mark your centers first. This has to be at the radius position for whatever it is you're making. So if I'm making a 1/2 inch diameter hole or circle, I need to have this set to the 1/4 inch. See, I'm trying to show you well. Trying not to move so you can see what I'm doing. So it's at the 1/4 inch mark. I'm holding it at an angle, but I'm not sure. Hopefully it looks clear on the screen. The pointy end without the lead, meaning the metal point end, that's what you put in the center. Okay. And, did you notice what just happened? This moves by itself. So this is I will call it a cheap compass. So be very careful which compass you buy. If you apply too much pressure to it, it will change the dimension while you're trying to work it. So sometimes that's why templates work better, because I don't have to worry about poor engineering of physical product. And your compass, you end up twirling it. Slowly. See how slowly I'm going? And it takes a couple of passes, and there it is. So you just want a circle. The next one is the 5/8 radius, if I remember correctly. It's on your drawing that you have in front of you. My copy is on the floor. There we go. A 5/8 inch radius is what you're after next, which is this arc. So in your auxiliary view, you actually draw the object in its true size. You draw the object in its true size, its true appearance. You don't worry about making those funky little elliptical shapes. The reason those elliptical shapes exist is because in that view, the object is not visible in its true shape, because you're looking at it head on instead of head on to the view, to this view, the front view, instead of head on to that specific piece of the view. That's the difference. If you notice, this auxiliary view is literally aligned with just that perspective. And because I'm lazy, and I would like you to be as lazy as me, and yes, it is recorded for life on YouTube, I intentionally recommend, so there you go, there's your shape. I intentionally recommend that you break. Let me finish putting in my center line, sorry. Break at the 1 inch mark right here. This is the 1 inch mark because from here to here is 1 inch. Why is 1 inch? Because that's the dimension that the customer gives me. Okay. That position, I break at it right there. So that way I don't have to draw the rest of the object in this perspective. That's a lot of extra work. I don't care to do that, and my employer, trust me, is not going to pay you to do that kind of work. So a break line looks like this. Looks like a heartbeat. All you need is one, because this is a small view. For bigger objects, you'll need more than one heartbeat. But it just looks like a heartbeat. Notice how that looks? That's all. But it's a little triangle above and below, not just one. It's a heartbeat. Okay? And that is your auxiliary view. Now you can go ahead and drop in all your dimensions with the rules that we follow. So when you look at this, the first dimensions you want to put in are these, the horizontal and the vertical. The last dimensions you put in are the radiuses. The last dimensions you put in are the radiuses. You never put in those first because they get in the way of everything else. Okay? The rule of thumb for someone who's detailed way too many times. So again, back to this. Putting in the dimensions. My first dimension over here. I am, again, lazy. My first dimension is 1/2 inch away. My second dimension is 3/8 away. Where am I getting these rules from? Not my head. There are standards that we're following. Okay? The handout that you have for that. They're spaced out evenly. Once you know the spacing, then you can go ahead and remember your first dimension, your extension line, never touches the object line that belongs to the object. It's always off of it. By what dimension? 1/8 of an inch. Remember that. 1/8 of an inch. So I threw those in because I have my reference ticks of where they have to stop. Since this is inch drawings, they're in ANSI standards. So ANSI standards, all the dimensions are horizontal. That's 1 inch right there. It's the 1 inch dimension right here. This one's going to be 0.25. Do you see how I put the dimension in before I'm putting the arrows? Get in the habit of doing that. That way you won't scrunch and realize you've run out of room. Your arrows go at the 1/2 inch mark. Say it at a 1/2 inch from the part. See that? That's for the first dimension. You see now I realize, well, the dimension's going to take up all the space inside the gap. So where do my arrows go? Outside. Just kick them out. So what? That's okay. In here they're scrunched inside, right? I don't care. Your dimensions need to be 1/8 inch tall. So you don't scrunch them. Do not scrunch your dimensions to make them fit. You always put your number in first, then you put the dimension lines in. That way you'll get it right. This dimension here, because this dimension is out here, that is why this last dimension is out lined up with this. Okay? That is the reason for that. So there are two ways to dimension, because this is that unknown number, the one we're making up. We're assuming that it's 3/8, right? From our previous conversation. So we can do it one of two ways. You can put in 0.38 with the letter A next to it. That's the way I recommend your class does it. Sometimes people will just put the letter A in here and then reference to the note. I don't care which way you do it. But I would recommend you do this. Put the number and then the tag next to it. Okay? That's this side. Then you do the vertical. Same process. And as you put in your dimensions, you always mark them off your reference sheet. That way you don't miss a dimension. And remember, you must dimension things as they are presented to you. You cannot decide, I'm going to dimension something else. Because remember, where these dimensions are located also define the tolerance of the drawing. The tolerance of the drawing. And the tolerance of the drawing is necessary to build what is pictured correctly so that it fits together with whatever else is going on with it. Because we don't do drawings for the sake of drawings. We do drawings so that we can build product. Because that's what the company makes money off of. They don't make money off of you drawing. They make money off of the product that is made. Does that make sense? The product. So your drawings need to be correct, because if the product comes out wrong, there's recalls, people get hurt. We had this conversation before. We don't want to make those kind of mistakes. The first dimension is 1/2 inch, second dimension is 3/8. 1, 2, 3. Okay, notice how I just put the little dots there as reference. That's all you got to do. Some people feel they got to make big markings everywhere. Nope, don't have to do that at all. Just make sure your dimensions do not touch your object. They need to be 1/8 of an inch away from the furthest element. See that? See how they're all gapped away? That's how you do it. Your dimension extension lines do not touch the object. Okay, so that's where this one will go. That's 1.25. 0.25. Again, notice I put the number in first. That's how I realize I don't have enough room for the arrows. So what? No problem. Identify where they're going to go. They just go on the outside. Your numbers need to be roughly centered in the space. See that? Roughly centered. Remember the trick I gave you last time regarding the use of your, until you learn how to draw 1/8 inch or close to 1/8 inch tall? Use your eraser shield. The big wide one, not the little narrow one, because this one literally is 1/8 of an inch. So mine's just a little big. That 1 1/4 is a little bigger than 1/8, but that's okay. A little bit's all right. What you don't want on your drawing is like drastically different sizes. Okay? And you don't want to draw too tiny. So I usually say use the bigger slot right here, because then you could draw right inside of it. And your numbers will come out about 1 1/4 inches with no problem. Okay? So now, when this is drawn, I'm not ready yet because I got to finish my dimensioning here. Because these dimensions I haven't put in yet. So I got this in, this in, this in, this in, and this in. So the next ones I got to do are this, the angle. Okay? And then I've got my radius and that. So on this side, here's the nice part. Because you already took the effort of identifying where the dimensions go here, guess what? Do you need to re-identify the 1/2 inch mark on this side? Nope. Because it's already there for you. See that? So you don't have to redo that work. Remember, work smart, not hard. Always work hard, but work smart. So that's 0.25 right there. Now that's a little big, to be honest. If I had to be picky with myself, which I am. So I made it just a little smaller, just to make it a little better. Okay? That's the thickness. Counterbore information, we're going to pull off the front. We're going to put it as a note. The other piece that's missing, the 135 degrees. This is where your compass comes in again. And your handy dandy little piece of tape. So that you don't rip a hole in your paper. Okay? So you just locate in relationship to that intersection, get kind of close. And you draw a little arc like that. Little arrows at the end, little narrow arrows, and put in 135 degrees. Okay, that's it. Here is actually where I'm going to put in the information regarding the, I have to clean it up. I got to erase some lines here. But here is where I would put in my 1 inch reference. Those are my cut lines, my reference lines. So I'm going to start my dimensioning off of that. I only need the 1 inch dimension. So I just need this one, and that's 1/2 inch away. Whoops, leave my light board on. Sorry about that. My T-square is not straight. Stuck on something. If your T-square starts bothering you, you might have to literally flip how you're using it. Which means you also flip how you're using your protractor. Notice how I'm turning it around to figure out what is the correct angle that this is supposed to be at. I keep hitting the light button. Sorry about that. Go there. And here. And then here. And even here, your dimension goes straight. It doesn't align with anything. It's horizontal. Okay, there's your 1-inch mark. Now, that's in. This is in, and this is done. The only thing missing is this radius, the diameter, and that. So this is where your other angles come into play, because you will not be able to put everything at a 45-degree angle. So you might have to use your 30-60 triangle, which is this guy. So off over here, for this drawing, I can probably get away with, and I'm going to. There we go. Sorry about that. Okay. I'm going to go off at an angle over here for the radius. See that? How I drew that line? How far away? Not too far, not too close. I know that's a really bad answer. If you can stay within the existing dimensions that you have, you're good to go. So the one dimension is this guy. The radius 0.25. So R 0.25. See that? Okay. On the opposite side, I would dimension to the inner object. See that? Put the arrow to the inner object. Now notice how I centered it. I made sure whenever you're dimensioning anything that's round, you always center your leading arrow to that object, to the center of the object, the center of the arc, to the center of the circle. You don't put your arrow in the center, you put it to the perimeter of that object. See where the arrow is to the perimeter of that arc? And there's the radius. But this line that leads to it is centered to it. Ditto for this side. This is the interesting one. This is the one that has the counterbore information right here. So a little bit on top and a little bit on the bottom. I like to center my work. So diameter 0.13 through. Diameter, oh, what did I miss? The counterbore. The little counterbore looks like a letter U, but actually looks like the goalie posts from football. You know when you think about it? Sharp U. Counterbore, diameter 0.25 at a depth of 0.13. See that? That's it. That's all you have to do. And then here are the next two. Now this is the one where I say you're going to have two different angles because at 40, this is at 45 degrees, right? So you can't use 45. So that's okay. You freeform it. As long as it is centered, see what I'm doing with my, rotating my straight edge? Doesn't matter. It can be angled somewhere else. See that? I can drop this here. Okay, and then I can, they both share the same center, that's why I keep doing this. And then I can just drop this one a little further down. The arrows must be pointing to the center of what they're dimensioning. Remember that. Can't be pointing anywhere. Then on this edge I can draw the straight line that will represent the where now you would put your text. Because your text for this hole is diameter. You have to give yourself enough room. So if you're unable to assess mentally how much room this takes, write backwards. Until you, meaning that instead of starting with diameter 0.5 through and then run out of room, crunch into, go backwards. U, R, and I know this is hard. H, T, see that? Spells through, but I wrote it backwards. I started with the letter U, which is the closest to the line, and then the R, and then the H, and then the T. Get it? I just literally wrote backwards. And then the 0, the 5, the period, and the diameter. Until you learn spacing. That way you know you're not going to scrunch your letters. When you learn spacing, then you'll be fine. You'll know about how far to put it away. Until then, just work backwards. It's my word of advice. And there you have it. Okay? Now, if this was on a board or paper, we'd be done, but it's not. I left it on this paper just to get through the conversation so I wouldn't be switching papers in the middle of the presentation. So, but if I wanted to, just to give you a little overlay, that's what it would look like on bordered paper. And I have had students literally draw on blank paper and then use it as their guide on the final copy. Some people have done that. The light boards are not expensive, not that I want to be a salesperson for them, but that's kind of how you do that, the tracing, okay? But you trace lightly and then you go and use a real ruler. Otherwise, it's going to come out really bad. So don't trace. Trust me, that's like just do a trace and then turn it in because your hand shakes. You can't trace correctly. You need to use a real ruler and draw real lines, okay? But that's basically what this is going to look like. The scale for this is 1:1 because when I do the overlay, it looks good. 1:1 will be just fine. The gaps we used are decent. The drawing is about centered, so it looks nice. So it will look good on this piece of paper. About 2.5 inches in, 2.5 inches down. The two views are about 2.5 inches away from each other based on this position, if I remember correctly. Let me double check. Yep, they're 2.5 inches away. 1, 2.5. Okay? So 2.5, 2.5, 2.5. I don't care how close this is to the edge, this side. We need that room because we have this view here. Okay, and that ends this video.